Matt Parker from Stand Up Maths posts puzzles periodically. This is my attempt at the marching band problem. The puzzle is this. You are creating a marching band. Your marching band must march in rows, but each row must have an equal number of performers in it. You want your marching band to be able to march in exactly 64 different formations. What is the fewest number of performers you require for your marching band to have 64 marching options? In the case of a 12-person band, it can have 1, 2, 3, 4, 6, or 12 rows, which correspond to its factors. This means that this puzzle is asking for the smallest number that has exactly 64 factors. Since I'm learning Python, this seems like a perfect opportunity to brute force the solution. A little while later, turns out the solution is 7,560. Initially, I had a bug in the code that caused it to look for the smallest number with 65 factors, which is astronomical. More on that in a bit. While waiting for it to finish, I decided to see if I can find the answer another way. Since all composite numbers are products of prime numbers, it makes sense that the smallest number you can make by multiplying primes is to repeatedly multiply the smallest prime, 2. To test my hypothesis, I decided to try smaller numbers of factors. This is what I found. We see that the numbers fall into one of two categories. They're either a power of 2 or a multiple of 12. Another thing I noticed is that the numbers that are a power of 2 are the ones that have a prime number of factors. I thought maybe this has something to do with all these numbers having a common factor with 12. So I tested 35, which is a composite number that has no common factors with 12, but I got 5,184, which is a multiple of 12. To make matters worse, while making this video, I realized that 65 is not a prime number. If my pattern is correct, the answer should be a multiple of 12. But I let the program try numbers up to 250,000 and it didn't find a number with 65 factors, which leads me to believe that it's a power of 2. It's worth noting that while the number is not prime, its factors are 1, 5, 13, and 65, none of which are shared with 12. I don't know where to go from here. I got the answer to the puzzle, but I have so many questions left unanswered. Hopefully Matt will touch on this in his solution video. Since this video is about a math puzzle and mathematicians love circles, here's 20 seconds of a rotating circle.